Everyone, I am Mehak Afreen, studying MTech in the field of computer science from Bangalore Institute of Technology. Today my project title is DHCP Server Configuration to assign the IP addresses dynamically using NS2. Here we are going to study that how DHCP server can configure to assign the IP address using the NS2. NS2 is nothing but the network simulator in which it's discrete the event simulator which is widely used in researchers and academics to simulate the network protocols like TCP, UDP, etc. and wire and wireless networks here, and also packet routing and congestion control and also performance analysis, which we're going to learn further. So next dive into the topic and see. So the main objective of our project is to demonstrate a DHCP server functionality using the NS2. As I told you, NS2 is the network simulator 2, in which it's a discrete event network simulator widely used in researchers and academics, like for network protocols for UDP, TCP, and for wire and wireless networks, also for the packet routing, congestion control, and performance analysis. And also we simulate the dynamic IP addresses assignment to the client, and also here we observe and also validate the DHCP behavior in a network administration. And the goal of this project is to simulate the real-time working of DHCP server in NS2 and showing how to assign the IP address dynamically and also managing the network efficiently. So, coming to the main topic, what is DHCP? DHCP is a dynamic host configuration protocol which automatically assigns the IP addresses to the host, and also it eliminates the manual configuration, ensures efficient uses and the reuse of the IP addresses, and also essential for scalable dynamic network. And the key points to remember about the DHCP is that it stands for dynamic host configuration, and also it automatically gives IP addresses devices, and there is no need to manually assign the IPs, and also it saves time, avoid IP conflict, and also it supports for the large networks. And here this while it avoids the manual configuration and ensures the efficient use of the available IPs, also save times, and it is very scalable in nature. Coming to next, as we have learned what is DHCP, and let's learn how DHCP works. It works in four-step process. First one is DHC discover, DHCP offer, DHCP request, and DHCP acknowledgement. It is a DORA process in which the DHCP discover does that client broadcast a request for the IP. Here the client requests the broadcast of the IP addresses, and in DHCP offer DHCP server responds with the available IP and the configuration information. Coming to the DHCP request, here the client requests the offered IP, and then in DHCP acknowledgement, server confirms and leases the IP. This is the work that DHCP does in the four process. And in the first, as I told you, that the client sends a discover request, then in the server offers an IP, then the client requests to use it, and finally the server combines and allocates that IP. These are the four processes in which the DHCP works. Coming to next. We have learned about the DHCP and what are the four processes that how DHCP works, and now next we'll learn about why we use DHCP. As DHCP is preferred here because it makes the network management easier, and also in that it makes more efficient, especially in the large and frequently changing environment. Why it is useful? Because it automates the IP configuration and also it prevents the addresses conflict. Like it provides different addresses for different this one system, and it also centralizes the management of the IP addresses and also useful for the dynamic and growing networks. So coming to next. So let's take a real-time example for DHCP. And here you can see that if you start a workday in a corporate office, you bring your laptop and plug into the LAN or connect to the Wi-Fi of the office. And the moment you connect the laptop, it automatically gets an IP address, like example that is 10.0.0.105, without you doing it anything manually. And this IP addresses along with default gateway, subnet mask and DNS server is assigned by DHCP server in your company's network. And here the main router or a dedicated DHCP server is used. And this DHCP makes very work easy, as it automatically assigns the IP address rather than you do it manually. And here you don't need to configure anything, it always does automatically, and it reduces the work as it is automatic configuration of the IP and not the manual one. Next. You can see now your laptop can access the internet and also connect to the internal systems like printers, file servers or any of the internal apps. And also we can use tools like MS Office, Outlooks or any of your company internet. After the few hours or the few days depending on the lease time, the IP addresses may change automatically if you reconnect all handled silently by DHCP. If you connect the laptop to the LAN or the Wi-Fi, after many hours or days, the IP addresses can automatically change if you reconnects, and this is all thanks this goes to the DHCP, which does this automatically and no manual configuration is required here. Next. So coming to NS2, as I told you before, let me give a short introduction about that again. And it is nothing but a discrete event simulator used for simulating the computer networks. And here it simulates the network behaviors, protocols, and also the performance analysis. And it is used in the both academic and researchers purpose. And here it is developed by the UC Berkeley, and also it is supported by DARPA and NSF, and it is also maintained and extended by the researchers and the contributors worldwide. Next. The input and output of this NS2 simulation is nothing but we write a simulation script in OTCL, like example.tcl, and we run it using the NS command, like example it is NS command.tcl, and output here includes with the .tr file in which it traces all the network events, and also the num file used for the animation in num. Coming to the advantages here, it is nothing but free and open sources, large community support, and also it is well suited for the protocol development and testing. So here it is very clear that we can say that we use this OTCL scripts also to define the simulations, and running them in the NS2 produces the TCL files for the data, and the NAM file here is to visually show the network behavior. So next. So coming to the network topologies, we can say that our simulation includes on one server on multiple clients, and all are connected with a point-to-point links, and the server dynamically assigns IPs from the pool. And this is the network topology which are used, in which the multiple client nodes are there, and it is also connected point-to-point links between the client and the server, and here the server assigns the IPs from the predefined pool. Next. The simulation setup here is nothing but to simulate I used a Ubuntu through the PSL, and also install the NS2, that is the network simulator 2, with all the dependencies that is required to run, and also wrote a TCL script with a simulating DHCP logic, which is shown further. And next, run script using a NS command is used. This is the simulation setup which is done. Coming to next. As we have learned about the DHCP, the uses of DHCP, and also the process, that is the 4 steps that DHCP used, now we see how DHCP logic is there in simulation. It's nothing but the DHCP creates an IP addresses pool in this, and also the client requests the to the server, and next the server assigns all the next available IPs, and next output logs are shown to the client to IP mapping in this DHCP logic simulation. As we can see that these are the logic which is the DHCP requires in this simulation. Coming to next, we can see that. So here we can see that this is the DHCP simulation TCL script, in which it requires the one server node, 3 client node, a pool of IP addresses, and the function to assign the IPs to the client at the scheduled times. And here it doesn't implement any of the DHCP protocol packet. Instead, it only simulates the logic and prints the IP assignments to the console. Here let me give you step by step explanation of this code. Here the first is the create simulator and add trace file. Here the new simulator is nothing but it creates the ns2 simulator object, and coming to the open out.trw, it opens a file out.trw for writing the simulation trace data in which the network events can happen. And coming to next, the trace all nf, which saves the all events, that is the packet sent or received etc into the trace file. This is the first step which we have to do. And coming to the next step, that is the creating the node. The node contains one server and 3 clients, as I mentioned before, in which the server is the DHCP server and the clients are that is C1, C2, C3 are nothing but the client devices. And next is to create the links between the server and the client. Here the duplex link nothing but it creates a two-way communication link between the two nodes, and here the 10 MB is nothing but the link bandwidth, and the 10 ms is nothing but the delay, that is the latency, and the drop tail is nothing but the queue management type, and also the simulation, that is this, it is in a simple FIFO, that is the queue format. And next, coming to the IP pool, we can say that the IP pool, that is the list of the available IP addresses of the client. And also we can say that the IP assignment, that is in IP assignment is nothing but here it stores the all the client which has got the IPs. So coming to the next. The next step here is the DHCP assigns the procedures. It is nothing but it checks that if there are any IPs that is available in the pool, and also it takes the first IP that is needed to the pool of the IP pool, and that is in the form of the index, and also it removes any of the IP from the pool which is not required, and again it puts the DHCP server with the assigned IP to the client, and also it puts the DHCP server with the IPs that is left for the client, and here that it is stored in the IP assignment array, and also it prints the assignment to the console. Coming to the next step, we can say that the schedule DHCP request, it just calls the assignment protect at the times, and here at 1 second we can see that it assigns IP to client 1, at 2 seconds it assigns DHCP to the client 2, and also next it assigns with the DHCP to the client 3, and for the end of the simulation we can say that at point 6 it finishes, and also saves the trace files and also close the trace files and also print the simulation is finished and it exits the simulation. This is all about the trace script which I have told here. Coming to the next, we can see that. So here we are running the DHCP simulation using the NS2, and here first we have taken the CD, that is you are moving to the home directory, that is this symbol which tells that the home folder is in the Linux. And next, coming to the nano DHCP simulation.tcl, that is you have opened a TCL file, that is the DHCP simulation.tcl, in which the nano text editor here is to write or edit the simulation script that I explained you in the previous slide. What are the how the DHCP script, that is the how the IPs are assigned to the clients, and dot TCL is nothing but the scripting language used by the NS2 to define the simulation. And coming to the NS DHCP simulation.tcl, here it is nothing but we can say that this DHCP simulation is done in the TCL. And next, and here you can successfully see that how the DHCP servers are successfully assigned to the IP address to the three clients, that is C1, C2 and C3, and IPs are of the form 192.168.0.x subnet and the common private IP range. And here you can see that your simulation is finally successfully done, and all the IP and the DHCP server, it assigns all the IP addresses to the client. As we can see, we have successfully built our project using that is the DHCP simulation using the NS2. Next. So here is the sample console output as I showed before in the command prompt, and here we can say that each client gets the different IPs to the different clients, and here the DHCP server has successfully assigned the IP address to the successful clients. Coming to next. So we have come to a conclusion of our project, that is the DHCP simulation using the network simulator. In this we have demonstrated an DHCP functionality in a simulated NS2 environment, and also we have validated the automatic IP allocations, and then we have also built a foundation for a deeper network protocols simulation, and also we have gained the hands-on experience with the NS2 scripting, and we have done a successful project in which DHC server have assigned the IP address in the NS2. So this is all about it. Thank you so much everyone.